Hello, good evening. Am I audible? Am I audible? Hello, please comment. Am I audible? Everyone join the class. सब बच्चे ज्वाइन हो जाइए. Am I audible? Join the class. Hello, good afternoon. Good evening. बाकी बच्चे लोग कहाँ पे हैं? सब लोग ज्वाइन हो जाइए और क्लास का मजा लीजिए, आनंद लीजिए. Am I audible? Please comment. Am I audible? Please comment. Yes. Okay. Bonfire. Bonfire की श्रेया. Okay. Very good. After 1 to 2 minutes, then I will discuss it. सब बच्चों आ जाइए और क्लास का आनंद लीजिए. मंगल क्लास का आनंद लीजिए और सब लोगों का मंगल चाहिए. Today our discussion topic is preliminary class, that is real analysis. Okay. So let's start. Let's start it. Okay. So first is, what is set? What is set? So set is collection of well-defined object. Okay. So set means the collection of well-defined object. Next, notation of a set. Set basically we define second bracket. Okay. And their entries is element, every element. Okay. If A, B, C, three member, then we put second bracket this three member ABC. So ABC is the element of a set, we called. Okay, and we denote it by second bracket. Got it? Next, cardinality number of a set. Okay, cardinality means length, the number of member in a set X, and it's denoted by n of X. Okay. Here, for example, if we consider A, B, C, D, the entries of a set, so here 1, 2, 3, 4, 4 member, so that is cardinal number of a set is 4. Okay. Sohum Roy. Hi. Hi Sohum. Next, finite set. If the set has finite number of element, okay, then it's called finite set. If example, if we consider alphabet, English alphabet. So we know that English alphabet set entries of a set member is A, B, C, D, E, Z, that is 26. So finite set, the countable number of the element, that is finite set. So finite set, if the set has finite number of elements, that is length less than infinity. Okay, so first page is clear to everyone. First is set theory. What is set? Set is a collection of well-defined object. Next, notation of a set. Basically, we notate set is second bracket, okay, and entries of a set elements. Cardinal number of a set. The number of member in a set X is denoted by n of x. So if we consider A, B, C, D this element, so here 1, 2, 3, 4, that is n of x equals to 4. Finite set, if the set has finite number of elements, then it's called finite set. Is it clear to everyone? This page? This page clear to everyone? Please comment. Please comment. This is clear to everyone? This is clear to everyone? Okay. Now go to the second page. Second page, infinite set. So what is infinite set? A set whose element cannot be listed counted by a natural number. Okay, not finite set, that is infinite set. 1, 2, 3, 4, 5, 6, so on. For a finite number of element is called finite set, and this not countable, that is infinite set. Okay. For example, a set of all plane points in a plane. Okay. So basically y equals to x is a straight line equation. So if we draw this straight line, this type of straight line, y is equals to x, y equals to x. Okay, clear? So here infinite number of point exist. So this is infinite set, a set of all points in a plane. Clear to everyone? Also another example is if we consider 0, 1 belongs to x belongs to 0, 1. So here infinite number of point, because x belongs to, if we put x belongs to R, there are infinite number of point in a set. So this is a infinite set. Got it? So infinite set, a set whose element cannot be listed counted by a natural number 1 to n for any number n is called infinite set. Okay. So infinite set is counter example, we consider a set of all points in a plane. So if we consider y equals to x straight line, so we get infinite number of points there exist. So this is infinite set. Also another consider a set if we consider x belongs to R and x belongs to 0 to 1, there are infinite many point exist. So this is also infinite set. Is it clear? Singleton set. A set consisting of a single element in a set is called a singleton set. If there exists single element, then it's called singleton set. Now we draw a counter example. X belongs to natural number. So if we consider x belongs to 1, 2, 3, so here natural number only exists 2. So that is 2 only exists. So 2 is a singleton set. So n of x equals to 1. So this is a singleton set. Okay. Is it clear? This page is clear to everyone? Please comment. This page is clear to everyone? Please comment. Comment कीजिए. Okay. Now go to third page. Singleton set. Okay. Singleton set, a set consisting of a single element is called a singleton set. Consisting single element. Now see a counter example. X belongs to 1 to 3. Okay. And x belongs to 1 to 3 and x belongs to natural number. So here natural number exists only 2. So here singleton set is only one member exists. So n of 1 equals to n of x equals to 1. So this set is called singleton set. If there exists only one single element, then it's called singleton set. Clear? Clear to everyone? Is it clear? Now go to third page. Null set. A set has no element. This is called null set. Okay. If there exists no element, in a set, then it's called null set. Now we see that a counter example. So we put x belongs to R. Okay. R means real number. Okay. And given condition x square plus 2 less than 2. So x square plus 2 less than 2, that is, we can also this write x square less than minus 2. This also we can write x square less than 2y square. Okay. So this is the imaginary field, not an exist real field. So there exists no element in the set this satisfy x square plus 2 less than 0. So this type of example is called null set. Is it clear? Is it clear to everyone? A set has no element in a set. A set has no element. Then it's called null set. Okay? Clear? Clear? Equivalent set. Two finite set A and B are equivalent if their cardinal number are same. That is n of A equals to n of B. Okay? Equivalent set, two finite set A and B are equivalent if their cardinal number are same. That is n of A equals to n of B. Okay? Is it clear? Now, universal set. If it is a set which included all the set under consideration, it is a superset of each of the given set. Okay, universal set. Universal set means whole total of the set, and this is called universal set, and it is superset of each of the given set. Clear? Null set, equivalent set, and universal set is clear to everyone. Null set means the set has no element, contain no element, that is called null set. We can write a counter example. If we consider x belongs to R and x square plus 2 less than 0 given condition, there are no element, any element x, this satisfy this condition. So this type of example is called null set. Okay. Equivalent set, both two finite set, same cardinality. That is called equivalent set. Universal set, that means whole, total set. ঠিক আছে? That is superset of each other given set. That is called universal set. If we consider given A equals to 1, 2, 3 and B equals to 4, 5, 6. ঠিক আছে? So if we draw this graph, क्या हो गया? Hmm. So this is A set, this is B set. Okay, if we draw, this is A set and this is B set. And A set under this set and B set also under this set, this type is whole, this set is called universal set. Universal set is a superset of each of the given set. Okay, clear? Is it clear to everyone? Is it clear to everyone? Please comment. Any doubt, please comment. Is it clear to everyone? Is it clear? Please comment. No intersection. Also intersection of satisfy. Just I example this type of example. Okay. Intersection, complement, all satisfy. Also satisfy. A and B are disjoint set. This is also satisfy. If we consider this example, here A set 1, 2, 3 and B set we consider 4, 5, 6. They are disjoint. So this is also satisfied, obviously. If we consider a school and there are boys A set and girls B set. So they are always disjoint. So and school is universal set, boys is A set and girls is B set. They are disjoint. Is it clear to everyone? Is it clear? Is it clear? Now go to next page. Next, complementary set. Complementary set of a set A is a set containing all whose elements of universal set which are not in A. Okay. Complementary set, if given U, that is universal set, if we consider universal set member is 1, 2, 3, 4, 5, 6, 7, so 7. Okay. And here A set member is 2, 3, 6. Okay. So complement means does not belongs to A. Okay. So A complement is equals to 2 neglected, 3 neglected, 6 neglected. So A complement here 1, 4, 5 and 7. That is called complementary set. Is it clear? Is it clear to everyone? Complementary set means whose element of universal set which are not in A. Okay. Is it clear? Please comment. Please comment. Now, subset. Okay. Now, what is subset? A set A is said to be a subset of B if all the elements of A are present in B and is denoted by A, that is subset. This symbol is subset symbol. Okay. A subset B. Okay. If we consider A equals to 1, 2, 3, 4 and B equals to 2 and 3. Okay. So all member of the set, that is 2 and 3, this belongs to A. So here B is a subset of A. Okay. Here say that all the element of a set are present in B. Okay. So 2 and 3 all member of a set This is belongs to A. So B is a subset of A. That is subset concept. Clear? Next, power set. So power set, what is power set? The collection of all subset of set A is called the power set of A. Okay. So if we consider A equals to 1, 2, 3. Okay. So its possible subset we can write if we draw null set, if we consider only one put, if we consider only two put, if we consider only three set, and also we consider 1 2 set, also we consider 2 3 set, also we consider 1 3 set, and also we consider 1 2 3 set. So 1 2 3, 1 2 3 4 5 6 7 8. So these all are subset of A. Definitely we see that this is the all subset of A. So what is the number of the subset? 1 2 3 4 5 6 7 8. So if we consider 3 element of a set A, then the power set member of the power set element is 8. So obviously we see that there is the 2 to the power n types. Okay. So here is the 2 to the power n type member of the element of a power set. Is it clear to everyone? So here the power set means the collection of all subset of A. So this is a subset, this is also 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 subset, this also subset, this also subset. So here 1 2 3 4 5 6 7 8, 8 type of subset exist. So this is the power set of A. If we consider power set member is 1 2, there is 2 square, that is 4. Okay, is it clear? That is the concept of power set. Clear? Is it clear to everyone? Please comment. Please comment. Is it clear? Now go to next page. Universal set. If A and B are two sets, then union of A and B is the set of all those elements which belongs to either A or B. Okay. So what is universal set? Universal set means all those elements which belongs to either A or B. So that means OR case. Okay. All those elements which belong either to A or to B. Okay, that is called universal set. If A exists or B exists. Okay, and it denoted by A union B. Okay, and this is set defined we X such that X belongs to A or X belongs to B. Is it clear? Is it clear to everyone? That is called universal set. All those elements which belongs to either to A or to B. Okay, clear? Please comment. This clear? This clear to everyone? Now intersection set. So what is this intersection set? Both exist. Both exist. Author, that's me. The set of all those elements which here exist OR case Here we can call AND case. Okay. So the set of all those elements which belongs to both A and B. A and B. The set the set of all those elements which belongs to both A and B. So intersection of a set, is it clear? Is it clear to everyone? Now go to next definition. Difference of two set. What is difference of two set? If A and B are two set, then the difference of A and B is the set of those element of A which does not belongs to B. Okay. So if A and B are two set, then the difference of A and B is the set of all those elements of A which does not belongs to B. Okay. So if I consider A is equals to 1, 2, 3 and B is equal to 3, 5, 6, then we can write A minus B is equals to, here say that those element of A which does not belongs to B. So here we neglected, here exist, here 3 is exist which is belongs to B. So A minus B we can write 1 and 2. This is A minus B. Okay, is it clear to everyone? That is called A minus B. This type of question, if we read B minus A, so here X belongs to B but X not belongs to A. That is we can write 5 and 6. That is B minus A, and A minus B is equals to 1 and 2. Is it clear to everyone? That is called difference set. Difference of two set, that's mean one element exists A but do not belongs to another set. That is A minus B. If A minus B we can write, then X belongs to A but X does not belongs to B. If we write B minus A, then X belongs to B but X does not belongs to A. This is called difference of two set. Is it clear to everyone? Please comment. This is clear to everyone. This is clear to everyone. Please comment. This is clear to everyone. This is clear to everyone. Okay. Now go to the second page. Symmetric difference of two set. So what is symmetric difference of two set? So symmetric difference of two set is set of those elements which are obtained by taking the union of the difference of A and B, that is A minus B, and the difference of B A, that is B minus A. Okay, so like that means union of different set. That means A minus B union of B minus A. A minus B union B minus A, and is denoted by A delta B. So if we call, this is symmetric difference of two sets. Symmetric difference of two sets, that is we can write A delta B, and A delta B is equals to A minus B union of B minus A. Is it clear to everyone? That is called symmetric difference of two sets. Now next, Cartesian product of two sets. So what is Cartesian product of two sets? Cartesian product of A to B is a set containing the element in the form of order pair A, B, such that first A belongs to A and second B belongs to B and is denoted by A cross B. That is Cartesian product of two sets. Is it clear to everyone? So what is Cartesian product of two sets? Cartesian product of A to B is a set containing the element in the form of order pair. That is called order pair. First element we can put first A and second element we can put capital B and we denote it by A cross B. That is called Cartesian product of two sets. Is it clear to everyone? Is it clear to everyone? Now go to next page. Is it clear? Now, number and their set. So, natural number, some introduce of number. Okay. So, first we introduced symmetric difference. A union B minus A intersection by. We can also this type of equation we also call symmetric difference and this is also called symmetric difference. They are same. So first is natural number. So natural number basically starting from 1, 2, 3, 4, 5 so on. So here lower limit or lower bound is 1 but upper bound does not exist. Okay. So natural number starting from 1, 2, 3, 4, 5, 6 so on. Whole number starting from 0, 1, 2, 3 so on. Okay. Integer number we can write two symbol Z or I. Basically this type is 0 plus minus 1 plus minus 2 plus minus 3 so on. Z plus positive integer defined, Z minus negative integer defined. Okay. Rational number, if we can write P by Q form, PQ belongs to Z and Q not equals to 0, then it's called the rational number. Okay. So this some important note, in rational number the digits are repeated after decimal place, then it's called rational number. Okay. So in rational number the digits are repeated after decimal, that is called rational number. Okay. 0 is a rational number. It is remembered that 0 is a rational number because we can write 0 by 3, 0 by 5. This is the P by Q form and Q not equals to 0. So this is the rational number. Is it clear to everyone? Is it clear? Now go to next page. Irrational number, cannot rational number, that is called irrational number. Okay. So if we find what is the irrational number, in irrational number digits are not repeated after decimal place. Rational number has digit decimal place repeated, but here not repeated after decimal place. Okay, that is irrational number, we can easily find. Okay, infinity is neither rational neither irrational number. Okay, next, real number. Union of rational and irrational number is called real number. Okay. Now interval. What is interval? The set of number between any two real number is called interval. The set of number between any two numbers is called interval. So if we call closed interval, then this is symbolized this type, closed interval, and we can symbolize third bracket. Okay. And x belongs x, a less equals to a, x less equals to b. Okay. And open interval, then we symbolized first bracket. Okay, a comma b, and x belongs a less than x less b. Okay, if we consider closed interval, that is less equals to include a, and open interval does not include a, That is called open and that is called closed. Is it clear? Is it clear to everyone? Please comment. Please comment. Is it clear to everyone? Is it clear? Okay, very good. Now, go to function. Clear, 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 clear. बस आप रुको जरा. Okay. Next, what is function? Is most important. So first we read this definition. Let A and B be two given set let A and B be given two set if each element A belongs to A is associated with a unique element. This is the most important word. Unique, unique. Unique element B belongs to B under a rule F, then this relation is called function. Okay. So again, I read this question, this definition. Let A and B be two given set, and if each element A belongs to A is associated with a unique element B belongs to B under a rule F, then this relation is called function. Okay. B is called the image of A and A is called the pre-image of the under A. Okay. This type of definition, we consider a counter example, then easily we can sort it. Okay. So and also we can write here, and also we can write here. This is figure 1, this is figure we can say 2, and this is figure we can say F3, and this is we can say F4. Okay. So first we figure that is A set and that is B set, and here three element exist, A, B and C. Okay. And this is A element first map, this is element to B and P, and B map to Q and C map to R. This is the F1 type. Okay. Second, we consider here four element exist. We can say A, B, C, D. Okay. And this name is A and B here. And here element of B also four. And we can say that W, X, Y and Z. Okay. And A mapping from W, B mapping from X, C and D both are mapping from Y. Okay. This is the F2 set. Okay. And here we can also see that F3 function, not a function I called firstly, here A set member is three element, we can call it A, B, C, and here four member element exist, and we can say that this is set B, and A map to L, B map to we can say this M, and C where two side map, C sometime N and sometime O. This is the another we can define this type of relation, and also we can another this type A and B. Here three element ABC, 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 and this is the U, B, W. So A mapping from U and C mapping from W. B is does not any mapping any element. So everyone try this problem, which here we can draw three type of relation. One is F1, F2, F3 and F4. So everyone try and please comment which one, which are function and which are not function. Here I am draw four type of mapping. This is this and this and this. So everyone try which are function or which are not function. Okay, question is clear? Question is clear to everyone? First of all, say that everyone say question is clear or not. I mean to say that which option or which is function, is it function? First question is F1 is function or not. Second question is F2 is function or not. Third question is also F3 is function or not. F4 is function or not. So F1, F2, F3, F4, which are function or which is not function. Everyone try and please comment. Question is clear to everyone? Any doubt? Everyone try and please comment which is function or which is not function. This is the main highlight thing is each element of A is associated with a unique element B under the rule F. This is the main highlight. So everyone try and please comment F1, F2 function, and I mean you say that F1 this is function or this is function, but this is not function, this is not function. रिमेनिंग कैन रिमेनिंग बच्चों आप लोग ट्राई कीजिए और आंसर दीजिए. बाकी सब बच्चों आंसर दीजिए. रूपम ने बोला F1 and F2 function and F3 और F4 not function. बाकी बच्चों बोलिए आंसर क्या होगा. सब लोग ट्राई करिए और क्वेश्चन का मजा लीजिए. After 2 to 3 minutes, then I will discuss it. Rupam said that F1, F2 are function and F3, F4 are not function. और कोई कुछ बोलेगा. और कोई कुछ. और कोई कुछ. Question is clear to everyone? बाकी सब लोग आंसर दीजिए कमेंट सेक्शन में. बाकी लोग कमेंट सेक्शन में आंसर दीजिए. आंसर क्या होगा आंसर दीजिए. F1, F2, F3, F4. which are function or which are not function. Which are function or which are not function. Please comment. Which are function or which are not function. सब लोग ट्राई करिए और आंसर क्या आया है हमको भी बताइए कमेंट सेक्शन में लिखिए आंसर क्या होगा सोमजीत सोमजीत आंसर क्या होगा सोमजीत f1 f3 फंक्शन f1 f3 फंक्शन ओके और कोई कुछ और कोई कुछ बोलना चाहिए और कोई कुछ बाकी सब लोग कहाँ हैं राहुल ने बोला f1 f3 फंक्शन बाकी लोग सोमजीत कहाँ है कुछ देर पहले तो बोला था ओनली डेफिनेशन वही मैथ होगा तो दिस टाइप ऑफ क्वेश्चन इज आल्सो लाइक अ मैथ्स कहाँ गया सोमजीत सोमजीत बाकी सब लोग ट्राई करिए और आंसर क्या होगा f1 f2 f3 f4 this is the most important part function is most important part of the real analysis so it is most important so first we see first one option so first one is say that this is f1 so here first we read this definition a and b be two given set and if each element of a is associated with a unique element b belongs to b under a real f then this relation is called function okay so here obviously see that a is map b b is map from q c is map from r so definitely unique element map to unique so definitely this is the function so first one is function is obviously true okay next f2 so here we see that f2 so here if c and d if we see c and d which is same associated to same element b okay so here note we see that note every element of a should be associated with b ঠিক আছে unique associated of b but vice versa is not necessarily true okay so here c and d this is the this two element map from unique y this is true this type of is true hmm. This is true. So also F2 is true. Here B does not any associated, so F4 is not okay. And F3, this is not a function because here two element. This is map from unique. This is not possible, and this is possible. So this is the important note. Everyone write this note. Every element of A should be associated with B, but vice versa is not essential. ঠিক আছে? That's mean every element should be associated with B. That is C associated to Y, D associated to Y, but this is okay. But here we see that this is the associated one element. This is not a function. Is it clear to everyone? So here function is F1 and F2 function, but F3 and F4 not function. Is it clear to everyone? Please comment. Is it clear? Is it clear to everyone? Any doubt? Please comment. Any doubt? Please comment. Is it clear? F1 and F2 function, F3, F4 not function. Is it clear? Please comment. Is it clear to everyone? Is it clear to everyone? Is it clear? Okay. Our last page discussion. What is domain and codomain set? So domain, codomain and range of a function. What is, this is the most important part. Good. This is the basic structure of the real analysis. Okay. So what is domain and codomain? So domain means all possible value of x for which fx exists. Okay. All possible value of x for which f of x exists. If we consider fx equals to 1 by x. So here if we x belongs to 0, this is not exist. 1 by 0 equals to, that is infinity. So 0 is not a member of domain set. So domain set member is all possible value of x for which f of x exists. That is called domain set. Is it clear to everyone? Codomain set, which map that is set, that is codomain set. And range set for all values of x, all possible value of f of x. Okay. That's mean here x, here we can write here n to n map. Okay. So here n to n map. Okay. So here member is 1, 2, 3, 4, so on. Natural number, member of natural number 1, 2, 3, 4, 5, 6, so on. And also here exists 1, 2, 3, 4, 5, 6, 7, 8, so on. And we map this type of function is x square type. So if we draw x, if we draw 2, here image is 4. If we draw 3, that is map for 6. So if here domain set member is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on. So range set means ki, range set means is if we draw 2, here is exist 4. If we draw 4, here exist 8. If we draw 3, that is 6. If we draw 1, that is 1. If we draw 5, that is 10. But odd number does not exist in this range. So here exist odd number here is considered twice x type. This is the twice x. Okay. So here map is fx is twice x function. So here we draw 1, that is 2, draw 2, that is 4. So this there exist 2, 4, 5, 6, that is element. This is the range set. And here also exist 1, 3, 5, 7, 9, 11 also exist. So all member of the set, that is called codomain. And for all values of x, all possible values of x, that is called range. So obviously we say that range is the subset of a codomain set. Range is the subset of a codomain set. Is it clear to everyone? So that is range set and codomain set. Is it clear? Any doubt? Domain, codomain, range. Okay. Domains mean all possible value of x for which f of x exists. That is called domain set. All possible value exists. That is domain set. Codomain set, that is here this type of mapping is called codomain set. And range set for all values of x, all possible values of f of x, that is called range. So obviously range is a subset of codomain set. Okay, this is the domain set, this is the codomain set, this is the range set. Is it clear to everyone? Is it clear to everyone? Please comment. Any doubt? Any doubt? Any doubt? Please comment. Is it clear to everyone? Clear to everyone? Okay, thank you. Good night. Okay. Thank you. Thank you. Good night.